Why you can live in Hiroshima but not in Chernobyl. Both cities suffered a major atomic disaster where radioactive fallout was released. The bomb in Hiroshima relied on fissioning uranium-235, and the reactor in Chernobyl also relied on the same process. Hiroshima is now well off and prospering, while Chernobyl still remained uninhabitable. So what is the difference between these two processes? Well, obviously it's the amount of radiation, but let's try to get a better answer than that. To answer the question, first I'll tell you about basic nuclear fission, then I'll talk about reason 1, reaction mechanism, then reason 2, detonation type, and lastly I'll talk about waste products. So let me just quickly recap how an atomic bomb works in the reactor, because as I mentioned before, both processes gets their energy from fissioning enriched uranium-235. And if we want to make an atomic bomb, we want to burn and release as much energy as fast as possible. This is done by using a chain reaction. The chain reaction is if we have a lot of enriched uranium, then one nucleus might fission and send out a neutron. If we follow the neutron here, we can see that if it hits another nucleus, then it would also cause it to fission, and in that process it will send out 3 other neutrons and an extreme amount of kinetic energy as well. These 3 new neutrons can now collide with other nuclei, causing 3 new splitting and causing 3 new splitting. So in just 4 cycles, one neutron duplicated itself into 81. So that's what we want to do when we create an atomic bomb. And I thought it would be fun to show you exactly how much energy is in this enriched uranium. I've shown this with this animation here where the red is 1 kilogram of enriched uranium. If we fission all that, then we'll get the equivalent of 17 kilotons of TNT. That's the equivalent of all these blue boxes here in Mars. So it's crazy effective. Anyways, in a fission reactor it's different. We obviously don't want it to explode, but we want to have stable and constant power. So we can take the same process, but this time we will make sure that on average one splitting, the 3 neutrons are released. Only one of these neutrons will cause another fission, and we block the 2 other neutrons with control rods. Now let's talk about reason 1, reaction mechanism. In an atomic bomb, we try to burn through as much enriched uranium as fast as possible. But in a reactor core we will need plenty of material to keep this stable constant power going. We will need a lot more fissionable material and a lot more radioactive products just sitting in there. Because the power plant consumes the same energy as the atomic bomb, little boy, each 4 hours. And to give you some numbers, the Hiroshima bomb had 46 kilogram of enriched uranium, while the Chernobyl reactor had 180 tons nuclear fuel, which corresponds to around 35 tons of uranium-235. So there's an extreme difference here. Okay, now to the next reason, detonation type. Because the atomic bomb was detonated hundreds of meters above the city to maximize the yield. Furthermore, when the bomb detonates, then everything is just completely vaporized in the bomb. So all the radioactive materials are now vapor that can float around with the wind. By the way, that's why wind greatly affects the radioactive spread in an atomic bomb. You can see this in this picture where we have ground zero of the atomic bomb here, and then wind carries the radioactive fallout away. So this vaporization of the material and the spread with the huge bomb will just spread out all the material in a much bigger area. So firstly it will be removed much faster and the dose won't be as strong. And of course that's different from the Chernobyl explosion, where the explosion was caused due to pressure builds up in the tank, and so the explosion was much weaker. The area where the material was distributed around was much smaller than an atomic bomb, and also it left huge chunk of radioactive materials around the place. So the concentration was much bigger and much larger. Okay, this naturally leads me to the last reason, waste products. Actually, enriched uranium isn't that toxic compared to its fissionable daughter products, like cesium and iodine. These are the real killers, at least in terms of radioactivity. But in an atomic bomb we only have the 46 kilogram of uranium, and that's it. But in a reactor core we will have fuel rods that produce the energy all day long, and they will also, of course, also produce waste products all day long, and they have to be replaced, and they might just not be replaced from day to day. So radioactive fallout from weeks ago are just sitting in the reactor. So these reasons combined is why the Chernobyl disaster was much worse than Hiroshima, at least in terms of radiation only. So thank you for watching the video. This video was brought to you by my very generous Patreon supporters. Thank you.
You have no power here, Gandalf the Grey.
Formulas are a complete and utter waste of time.
Freddy, you okay?